All right, welcome back on this beautiful Wednesday. I want to take a look. We're going to go through the homework, make sure that you did the homework problems correctly, and hopefully move on. So let's talk about number 2. Number 2, you should have done your statement reason chart, just like normal. And you should have done AB equals DE. So AB equals DE. And then you should have done measure angle CAB equals measure angle FDE. CAB and FDE is that. And then our last given, measure angle DEF equals measure angle ABC. So ABC and DEF. Okay, and those are my givens. We want to prove that BC and EF are parallel. And we have been given this beautiful transversal. In order to prove parallel, we need those angles right next to the parallel lines to be congruent. So I need this angle right here. I'll do it in black. This angle right here and this angle right here to be congruent. And unfortunately, they are not congruent. At least not yet. We can make them congruent because we now have the information to make those triangles congruent. Because we could do angle, side, angle, and make those triangles congruent. We can do DFE is congruent to triangle. Okay, DFE would be green, black, blue. Green, black, blue. ACB. At that point, I can say measure angle DFE is equal to measure angle ACB because corresponding parts in congruent triangles are congruent. So now I've got those angles and I can go backwards and say, awesome, BC is parallel to EF, which is our mission. We need a reason though. Our reason, let's take a look. Reason always has to be congruent something, form parallel lines on transversal. Okay. And let's take a look. Are the triangles both inside my parallel lines? Are they both outside my parallel lines? One triangle's inside, one triangle's outside. So that would be form congruent corresponding angles. All right, so that's how we do number 2. Let's take a look for number 3. Number 3, we've got statement and reason chart. Start with our given, CB equals FE. Yep, FE. Given CB equals FE. Beautiful. Next one. AB equals DE. Given AB equals DE. So we got 2 pairs of sides looking promising. BC is perpendicular to AC. Given. Okay, we've got perpendicular on the board. Perpendicular means definition of perpendicular. Definition of perpendicular means 90-degree angle somewhere. There's a 90-degree angle somewhere. Don't know where it is. You need to find the 90-degree angles. That's what perpendicular means. Remember, that's perpendicular, not bisects. It's just perpendicular. So something is perpendicular. BC and AC are perpendicular, which means there is a right angle over there at C. Okay, so measure angle ACB is equal to 90 degrees. Okay. We're good? We're good? Next one. FD perpendicular to FE. Good grief, now we got it again. Okay, definition of perpendicular. Oops, this was a given. Def of perpendicular, which means 90-degree angle somewhere. 90-degree angle is FD and FE, so that at F is going to be a nice 90-degree angle. So measure angle DFE equals 90 degrees. Okay. Our mission is to prove parallel lines. So let's take a look at the parallel lines. This is a line, and this is my line. And here is my transversal right here, which means I need angle E and I need angle B. I do not have those angles, and I need those angles. Unfortunately, in order to do this, we're going to have to prove the two triangles congruent, which we could have seen coming. In fact, it was written on the cards. It was pretty obvious. We were going to have to prove the two triangles. That was basically what I've done for every single one of these problems. So, we're going to have to prove the two triangles congruent. But we have angle side side. That angle is not wedged between my two sides. The angle that I want right here, that angle is wedged between my two sides, but we do not have that angle. We have this angle over here. So because we have this angle over here, it's angle and it is not trapped between my two sides. And that is illegal unless the angle happens to be 90 degrees. Hey, look, we got 90-degree angles. So we are going to have to do an HL on this, which means HL to prove triangle ABC is congruent to triangle. Yep, DEF. Good job, squirrel. And what do we do when we have to do HL? Do you remember? Yes, we have to say that they're 90 degrees. Yes, because hypotenuses only exist in right triangles. So we need to say that triangle ABC and triangle DEF are what? Right triangles. Good job, squirrel. Just like that. Good job. But are we done? No, we've proven the two triangles, but we don't have the angles yet. Yeah, the whole point of proving the two triangles is to get to the angles and then to the parallel lines. I know, it's complicated. Okay, so we need to prove that measure angle ABC is equal to measure angle DEF by corresponding parts in congruent triangles are congruent. And then I can say, whoop-de-doo, BC parallel to EF. Exactly, squirrel. But can I just say that? No, silly squirrel. We need to say congruent blank form parallel lines on transversal. And take a look at my picture. Are they both inside, both outside, one inside, one outside? What's happening there? What are you doing? It's ridiculous. No, you can't eat the pen. Focus, squirrel, focus. Are they both inside or are they both outside? Or is one inside and one outside? She just can't focus today. It's alternate interior angles because they're both inside. You should have gotten that, squirrely. You should have gotten that. right, let's take a look at number 7. I want to go all the way down to number 7. If we take a look at number 7, statement and reason, I want to prove AB and CD. And we've got a whole bunch of transversals going on here. So let's take a look at what I've got for givens. I've got BE equals EC, given BE equals EC. And we've got E is the midpoint of AD. Okay, so E is the midpoint of AD. That means we've got midpoint going on. Midpoint means something just became two equal somethings. AD has a midpoint, so AD is cut into two equal pieces by E. All right. So that means AE equals ED. Okay. Well, at this point we can prove either the side triangles or the top and bottom triangles are congruent. If I prove the top triangle and the bottom triangle are congruent, or I could prove this triangle and this triangle are congruent, the side triangles. I want to prove the top two triangles congruent. Because if I'm looking at these parallel lines, an angle that would really help me would be if I were to draw the diagonal here and have angle D matching angle A. That would get me parallel lines. I could also go the other way. I could do the transversal over here through CD and have angle C matching angle D, and that would snap the two lines into parallel lines. Either way, I'm going to be in the pink and the blue triangles. So regardless of which transversal I use, I need to prove those pink and blue triangles are congruent. So I'm going to need, I've got two pairs of sides, need a pair of angles, and there's a beautiful pair of angles right there in the center. How do I know that? This was given, this was given. But when I run out of givens, there's two things I'm looking for. Reflexive and vertical angles. This guy's my vertical angles. So measure angle AEB equals measure angle CED, because vertical angles are congruent. And then what I have to do is prove those two triangles congruent. So I've got triangle AEB equals triangle, okay, triangle AED, so green, blue, orange. I need to go green, blue, orange again. So we're going to go DEC. And that's going to be side, angle, side. Okay, now I can get my two angles. Doesn't matter which transversal I use, as I say. We could use either transversal. I'm going to use the CB transversal. I'm going to get this angle and this angle congruent, just because. I could go the other way, doesn't really matter. So this is B and this is C over here. It's kind of got overdrawn. So I want measure angle ABE equals measure angle ECD, because corresponding parts in congruent triangles are congruent. and that will snap my AB parallel to CD because congruent blank form parallel lines on the transversal. And if you look, it's going to be both triangles are inside my parallel line. So alternate interior angles. All right. And that is how we do number 7. Before we move on, I want to talk about the difference between number 7 and number 8. Let's take a good look. Is the picture any different? I've got A, B, C, D, and E. So the picture should be exactly the same. Is the given any different? The proof statement is what's different. They want me to prove these two sides are the same. So I would not be able to use the pink and the blue triangles. I would then have to use the other two triangles. So 8, very interesting because it's exactly like 7, only instead of using those two triangles, I have to use the green and the purple triangles on the side. Those are the two triangles that I need to prove in order to get a nice angle on a transversal like that. And that is how we're going to do number 8. Now, don't need to do number 8 right now, but I want you to keep that in mind. 7 and 8 are very, very important to me, and I'm about to tell you why. It's quadrilateral time. So we've talked a lot about quadrilaterals. You've had that chart. We've done a lot of practice with the chart. You're going to need to keep memorizing the chart. Good luck with that. And the chart starts with what? Quadrilateral on top. Quadrilateral has 3 different babies. It's got the kite, it's got the trapezoid, and it's got the parallelogram. Trapezoid then had 2 different babies. That was the isosceles trapezoid and the right trapezoid. Parallelogram had 2 babies. That would be the rectangle and the rhombus. And then rectangle and rhombus had a very special relationship and made a square. Hey, they've got issues. What do you want? Now, we are going to prove quadrilaterals. In order to prove quadrilaterals, it's going to be somewhat difficult because in order to prove a square, I need to prove that it's a rhombus and a rectangle and a parallelogram and a quadrilateral. This is going to be a very complicated process. Most of the time, thankfully, they're not making you prove it's a square. Square is the best thing to get as a given and the worst thing to get as a please prove it's a square. Worst thing. Most of the time, it's going to ask you to prove it's a parallelogram. So let's take a look at a parallelogram option. I'm going to do a nice parallelogram down here. Beautiful. I'm going to do A, B, C, D. And draw that right there. I'm going to give you some givens, of course. Given AD equals BC, prove ABCD. Oh, no, there's 2 givens. I lied. Thank goodness. I was about to say 1 given is kind of, that's rough. That's just mean. A, D, B, equals measure angle CBD. All right. We're going to prove that ABCD is a parallelogram. Our mission is to get to parallelogram. Okay. In order to do that, we're going to do our statement reason chart just like normal. Okay. And we start with our givens. Always start with the givens. AD equals BC. So AD equals BC, given. Beautiful. Measure angle ADB ADB, so this guy right here, equals measure angle CBD, that angle right there. Given. All right. Well, at this point, I can prove triangles. I don't want to prove triangles, though. I want to prove that it's a parallelogram. So we're going to have to start up at the top of the list. The first thing that I need to prove is the fact that it's a quadrilateral. Okay, so if you take a look at the quadrilateral stuff, there's what, 2, 3 different things? First thing in a quadrilateral, it's got 4 sides. Does our shape have 4 sides? Yes. Okay, done. So we've got A, B, C, D is a quadrilateral. It has 4 sides. Vote. Okay, so we've proven it's quadrilateral. Now that we've proven it's quadrilateral, we need to make our way down to parallelogram. Okay, to make our way down to parallelogram, what we have to do is we have to use one of the many parallelogram properties. So let's take a look at parallelogram. Do you remember the 6 things that make a parallelogram? Most people remember the first one, 2 pairs of sides parallel. Okay, can I prove that 2 pairs of sides are parallel? Yes, I can. How can I do that? What can I do? Well, I've got angles here and here. So I want to prove that this side is parallel to this side. If I use BD as my transversal, I have this angle and this angle right there. So I can say AD is parallel to BC because of the angles. So I've got because what? Congruent something form parallel lines on transversal. Okay. So we've got, they're both inside. So that would be alternate interior. Okay. But there's a problem. This right here, that's 1 pair of sides parallel. Only 1. We would then need to erase that, and we would need to figure out how to prove these sides parallel, which does not include the green angles. It includes this angle and this angle. Could we prove that? Yes, we could. There's this transversal right here. We could use that as a reflexive side, get my two triangles, and everything would be good. I'm, however, running out of room, like super fast. Do you remember when we last did quadrilateral proofs and I said sometimes you don't always want to start at the beginning and the first one? Sometimes there are other ones that are more helpful. That's actually going to be the key for this as well. We've got 6 different things that prove it's a parallelogram. So let's take a look at the 6th thing that proves it's a parallelogram. The 6th thing that proves it's a parallelogram is one pair of sides parallel and congruent. Do I have a pair of sides that are parallel and congruent? Well, I just proved AD is parallel to BC, and my given said AD equals BC. So because of those two, I already have that it's a parallelogram. I can end this. I can say ABCD is a parallelogram because I have one pair of sides parallel and congruent. In fact, I did not even need this given. This given was there just to distract you. Could you have used it? Absolutely. If you had wanted to, sorry, not this given. That given was extremely helpful. That given was extremely helpful. Nope. I lied. You need both givens in this one. Because one given gave it, this one gave you the fact that it was congruent. So this one gave you the fact that the sides were congruent. And this one gave you that the sides were parallel. At which point you have one pair of sides that are parallel and congruent, which gives you a parallelogram. All right. So that's how we are going to be doing parallelogram proofs. Let's take a look at what I want you to do on the homework. Okay. We want to prove it's a quadrilateral. Nope. I want to prove that it is a parallelogram. Why is there no 1 here? All right. For your homework, what I want you to do is I want you to write those down, write down the givens, and try and figure out a strategy on how we are going to get a parallelogram out of number 1. Which of the parallelograms are we going to be using? If you think you can do the whole proof, go ahead and do the whole proof. But I want you to just think about what strategy we're going to use after you've filled in your givens, after you've done your chart. We're going to go over it tomorrow. And then tomorrow we're going to go on to angles. You do have a short quiz on Friday where it's just going to be a did you pay attention to my videos type of quiz. Notice, for your lab, if we go back to what our mission was today, we've done practice 2, we've done parallel lines. Today we did quadrilateral proofs. Tomorrow we're going to do angle proofs. On Friday, you're going to have that quiz. We're going to save practice 3 for later. The quiz is going to be like practice 3. You're just going to have a short movie on how to do the homework for the angle proofs to make sure you did it right. You're going to have a nice quiz on Friday. Now, for your lab, you should have gotten a review packet. Let's take a look at that review packet. You should have gotten something like this on the bus run. So if you take a look, this is all that we learn or will learn in geometry. You should have already looked at it and figured out what was happening. I want you to go all the way to page 27. So we're gonna speed this up. 23, 24, 25, 27. 27 is all about perimeter area and volume. So stuff that we've done a lot before. What I want you to do is I want you to try and figure out how many of these perimeter area and volume problems that you can do. That's what your lab's going to be. So if we go back to our map of what I want you to do, I want you to do the Regents Review packet. And I want you to do pages 27 all the way through 38. 27 through 38. Now that's a lot of pages. That's a lot of pages. What you're going to be doing is you're going to be working on them this week. That is your break packet. Your break packet, I always give a packet for break. I know you'd be very traumatized if I did not give you a break packet. Your break packet for the spring break is going to be doing pages 23 through 38 in your Regents Review packet. I will be posting some videos next week, not learning videos, just some videos on some of the questions for 27 through 38. So if you have a question on one of them, you have issues with one of the 27 through 38 pages, message me. And if it's a good question, if it's a difficult issue, I'll make a video of it so that you all can see what's happening and we can go through it. If you have any questions, of course, message me, and I will talk to you tomorrow. Have a wonderful day.